This is section 4, in which we shall look briefly at engine systems. There are two most commonly used types of engines that differ essentially in the type of fuel that they burn in order to produce their power. The first engine type we see here is a diesel engine, so called because it is powered by a fuel called dieseline or simply diesel. The next type is called an LP gas engine. It is virtually identical to a diesel or petrol engine in appearance. LP gas engines are designed to operate using propane, which is a gas. The most notable feature of a gas vehicle is the large gas bottle mounted behind the operator's seat. Regardless of the type of engine that an engine-powered vehicle has, there will be many common features. These features include the engine starting system, the battery charging system, the engine's cooling system, the engine's lubrication system. Let's briefly look at each of these. All modern engine-powered vehicles are equipped with electric starting. Power for the starting system is supplied from a battery. The battery supplies the necessary voltage and amperage to drive a starter motor. The starter motor is activated when the ignition key is turned fully within the ignition start switch. The starter cranks the engine, that is, it makes the engine's crankshaft rotate, and this causes the engine to fire. Once the engine starts, the key is released to the normal operate position and the starter motor kicks out. During every attempt to start an engine, the battery loses some of its electrical energy. However, this energy can be replaced by the next system that we shall look at, namely the charging system. The main component in this system is an alternator. The engine drives this device via a fan belt, so called because this flexible belt usually drives the cooling fan as well as the alternator. We'll come back to this in a while. All the time that the engine is operating, the alternator causes electrical current to flow into the battery. This current results in the battery being replenished or charged. Special electronic devices sense the battery's state of charge and prevent an overcharge condition by automatically reducing the alternator's output. Let's turn our attention now to the engine cooling system. All internal combustion engines generate heat as they operate. This factor cannot be prevented, but it has to be controlled. Without a cooling system, the engine would literally burn out with its own heat. The cooling system is designed to remove heat from the engine and transfer this heat into the surrounding atmosphere. If you happen to be standing behind the counterweight when an engine is running, you will feel this heat in the form of hot air being blown out. The most common way in which engine designs keep the engine cool is known as the liquid cooling system. With this system, liquid, usually water, flows around the engine's cylinders. The water picks up heat and gets very hot. The hot water then moves into a radiator where it gives up the heat as it passes through cores over which a draft of air passes. The air is caused to flow by the cooling fan that we saw a little earlier. In engines, there will be a fan belt. The fan belt is driven from the engine or crankshaft pulley. This in turn supplies power to both the alternator and to the fan. We will now look at the engine's lubrication system. Every engine type must be lubricated to prevent all the internal moving parts from wearing out. This is achieved by having a quantity of engine oil contained within the engine's sump. We can check the oil level in an engine sump with a dipstick. Within the engine, the oil is circulated under pressure to various vital parts with an oil pump. An oil filter is fitted to the lubrication system. The job of the oil filter is to remove any particles of dirt or dust that may enter the engine. At this time, you have an idea about some of the activities going on in and around an engine. This section would not be complete if we didn't have a brief look at electric vehicles and see how these are powered. Unlike engine-powered vehicles, electric vehicles do not burn fuel in order to produce power. The power is obtained from a battery, in fact, a very large and very heavy battery, normally situated beneath the operator's seat. The power required to move the vehicle and to operate the hydraulic units comes from electric motors. These motors are usually situated on the front driving axle in line with each front wheel. A separate motor is used to power a hydraulic pump. This pump, in turn, supplies hydraulic power to the lift and tilt cylinders and also to the power steering system. We have looked at the various power-generating units that you will most likely come across. We have seen that a forklift truck can be fitted with gas or diesel-powered engines, or it may be an electric or battery-powered unit. This concludes Part 1 of Module 1. In Part 2, we will continue to learn about the basic parts and components that all go together in the construction of typical counterbalanced forklift trucks.